All right, we'll go ahead and get started. I'm Krista Vinson, and thank you for joining us for NC Broadband Matters, Why Upstream Matters. Really looking forward to the conversation today. This is the second time that NC Broadband Matters has discussed upstream, but it's been part of our DNA as an organization since we got started approaching 5 years ago. Where we're really invested in how the power of modern high-speed internet can help place-based efforts and local communities contribute to the world. As we've been saying, it is all about the upload. And here to discuss the topic are the distinguished and highly knowledgeable Kent Winrich, Mark Boxer, and Doug Dawson. You've heard from several of those folks before, but welcome, Kent, to your first NC Broadband Matters webinar. I'll allow them to further introduce themselves. But first, I'd like to take a moment on behalf of our board to recognize with great sadness the passing of NC Broadband Matters immediate past president, Gene Scott. Gene had a long and distinguished career. Share a slide here. In telecommunications, most recently serving as general manager of Outside Plant, overseeing the broadband network of Greenlight Community Broadband. Gene was truly a friend to all who knew him, and he will be greatly missed. And I'd now like to welcome Doug Dawson, who's generously agreed to serve as NC Broadband Matters current president. Doug, if you'd like to get us started.
Doug, you're muted.
Unmute. You can all see that?
Yes, sir.
Okay, very good. So we're going to talk today about what we've learned about upload. And we had this 2 years ago, and at that time we knew upload was a problem, but in the last 2 years we have learned a ton about it. That's why we decided to repeat this seminar, because we now have a lot of experience and a lot of facts and are talking about, what we've really learned during the pandemic. So, before the pandemic, we really didn't have any appreciation of upload. I know myself, I mostly used it to upload files. Every once in a while I was impatient if somebody was waiting on it, on the other side of a phone conversation, but mostly we didn't really care all that much about it. But all of a sudden, the pandemic started making us use upload in a whole lot of new ways. And all of a sudden, it became a major topic for a whole lot of families. What we learned was the biggest problem with upload speeds was really supporting lots of simultaneous sessions, students and people working at home. Interestingly enough, also a lot of simultaneous sessions in neighborhoods of a lot of people in neighborhoods working at the same time. So, one thing we've learned is that upload speeds are a lot slower than what the ISPs are claiming in many cases. And so, we've actually gathered a lot of data. Again, it used to just be used for uploading files for most folks. Now, school and work servers connect. Zoom calls like we're on right now are a massive new use of upload. Cloud-based software. Since the pandemic, I myself now do all my Microsoft work in the cloud, which means all day long it's saving up there. I've also gone, as many people have, to the collaboration software, working with other people who are working at home so that we're doing things together at the same time. Either good or bad luck, but right when the pandemic hit, all the major gaming platforms went virtual. And so you no longer run to the store to get the disc. That's all moved to the cloud. And that just happened to hit us at the same time as everybody else with the millions of gamers. We are still uploading files. Video sharing and pictures, particularly on cell phones. We forget that all of us, 70 or 80% of the usage on our cell phones is actually done on our home Wi-Fi networks. And so it's uploading along with everything else every time you share one of your pictures to the iCloud. Security cameras are just growing and growing as a use. And the machine-to-machine language has been quietly growing. That's when your computer and your cell phone and your washer and dryer and everything out run out to talk to the cloud or run out to do software upgrades, all without you having any idea that it's going on. So that's a heck of a lot of uses for upload that really didn't used to be very big. Speed tests are really one of the most interesting things of the last 2 years because we've started collecting them in huge numbers. Local governments, states, federal agencies like the NTIA are collecting them, ISPs collect them. And so what we've learned is an individual speed test is not reliable because, you may have a bad Wi-Fi router at your house, or, there might be just something funky going on. But if we collect them in large numbers, they actually tell very good stories about ISPs, especially in a market where you do speed tests for all the ISPs. It becomes a very good way to compare them against each other. And so, what we've learned through speed tests is that, what ISPs often advertise and report to the FCC is very different than what we see in real life. So this comes from a real county that I did a study for. I'm the president of CCG Consulting, and we've done a mountain of work with probably 50 communities during the pandemic. So this came from 13,000 speed tests in a county in Wisconsin. I picked this one out because it's really typical of what we're seeing. The cable company is the only one in the county who's meeting the FCC definition of 25.3 broadband. They're averaging about 10 megabits upload. Everybody else is very much below that definition for download speeds. In this particular county, AT&T DSL was actually faster than the 3 megabits. Now, these are all average numbers, and so what we see in real life is the ISPs go, yeah, but I have some customers who are getting 30 megabits down and 10 up, and you go, well, that's fine, but look at your averages when I look at a lot of your customers. The fact is you're really not getting close to those numbers. That's the big controversy we're all having with grant filings, but the fact is county after county after county that we studied looks very much like this chart. I mean, the speeds are just not that good. And particularly when you start looking down at the ones that are 1 megabit and 2 megabits, we've learned that's just not enough for families to get by during the pandemic. It's very arguable that people say, well, 10 is plenty, and we'll be talking about that today. That's really the purpose of this webinar. But again, we also do surveys where we actually talk to people and ask them questions. We've done several a month, every month since the pandemic started. One thing that we've learned is about 30% of homes, including people on cable company networks, say that they have struggled because of their broadband connection. That's a lot. That's a whole lot of people. We've learned in rural areas, the people that had the 1 megabit, numbers in that last slide were just completely blocked. I mean, for folks to even get on a Zoom call, is just a hard time. What we also learned, which we should have figured out, but what we learned is businesses really struggle because we talk about people working at home, but the other side of that is the businesses who they're working with. And so, if a business has a cable company connection of a 20 megabit upload connection, but they're trying to work with 10 employees remotely at the same time, they have 10 upload links. They all hit their ceilings. So, the businesses who had remote employees actually were one of the hardest hit by that. They had a very hard time, really working with multiple employees at the same time. We should have expected that, but we've actually talked, one-on-one to probably 1,000 businesses in the last 2 years, and a lot of them really, really struggle with that issue. This came from just last month, so this comes from Sandvine. This is North America usage of upload by the way you use it. RTP is all that's what we're doing today. That's Zoom traffic. That's a protocol. RTP is a protocol that just describes real-time video usage. And so if you would go back and look at 3 years ago, that probably wasn't even on the chart for the top 10 usage of broadband. And so that the Zoom calls that we're on now have grown to be 15.5% of all upload traffic in all of North America. It's just a gigantic growth of stuff over the time. Amazingly, some of the other numbers I also pop out to me. Nest is just one vendor. Nest security cameras are 2% of all uploads. I mean, you start looking at the list, and the list from 3 years ago was a drastically different looking list. So we are really using a lot more upload than we used to. We've also learned a couple other lessons during the pandemic. We learned, which I didn't know, and I follow technology closely, the DOCSIS technology for cable puts the upload speeds in the noisiest part of their network. And that's a real problem because, they say theoretically we can do 30 megabits of upload, but they actually use spectrum inside of the cable network, and they're using the old channels 2 through 5. And if you're old like me, you remember that you never could watch over the air channel 3 or channel 2 very good, because if anybody, even in half a mile away, turned on their lawnmower, you lost your signal. That's the piece of the spectrum that picks up every kind of interference, microwave ovens, you name it, right? And so that's the part that's where they're still using for upload, and it's really a terrible piece of spectrum. And so the cable companies are not delivering the speeds they promised just because of the interference issues. We also learned that upload is shared by whole neighborhoods. We talked to a lot of people. There's one on our board who ran into this all the time. The whole neighborhood got locked up. Once X number of people were working, nobody else could get on to do Zoom calls or whatever. That's a very typical, we never had anything like that before the pandemic. We also have learned that when networks get as busy as that, what happens is they get even worsely busy, because what happens when you can't make a connection properly, your computer tries over and over and over behind the scenes to make that work. And so it keeps asking to send packets over and over again, which makes the problem even worse. And so cascading packet loss can really crash networks and make the performance really bad. That's why when you work at 2 o'clock in the morning, you go, this is great. In the daytime, you see problems, and it's from that kind of neighborhood stuff that's cascading. We also learned that a lot of ISP speeds fluctuate a lot during the day. Cable companies I have Charter, and man, my speeds are just up and down and up and down and up and down all day. Again, we assume that that's coming from this neighborhood sharing thing, but fluctuating speeds are a real problem, because because if you're on a Zoom call, when it hits the lowest speed, it cuts you off. And so, it's like, well, gee, it was good, and now it's not good. Now it's good again. While evenings used to always be, and still are, the busiest time in neighborhoods, daytime usage, because of all the people working at home, have really made daytimes busy. They used to just be empty on networks. People think that a whole lot of people are going to continue to work from home. This is a new thing. A lot of people are not going back to the office. It's something we got to deal with. Probably one of the most important things we learned, which we absolutely didn't know, was the network performance varies by neighborhood. We have studied in detail, by doing a lot of speed tests, cable companies and cities, and found that 1 or 2 neighborhoods were drastically slower than the rest of the city. The cable company knew those pieces of the town had a problem for years, but they didn't do anything about it. They've not fixed the problem. City officials have often poo-pooed people. They're going like, well, my cable works fine. It turns out some neighborhoods really do have bad broadband. And there's a whole lot of, we're not talking about it today, but there's a whole lot of technical reasons why one neighborhood may have really lousy speeds. And so, and of course, when you do these studies, maybe that's a time to get the cable company to finally get out and fix those problems. But it turns out that some of the people who've been yelling about slow speeds really have had the problems, and when their neighbor a mile away doesn't have them. So overall usage has just exploded, and that, it's not just the upload has done it. We have learned that, they started measuring and upload during the pandemic. No one really paid attention to it before. OpenVault in their latest report said that the average home uses 25 gigabytes of upload now every month. That's a number that would have just astounded a network engineer 5 years ago. They're like, you hardly use it at all. That's a lot of usage. And so, that's a pretty big number. So, and really for the first time, homes care about upload. I mean, they may not know they do, but when they talk about having slow broadband, that's almost always what they're talking about. Here's just a quick chart of how overall, this is upload and download together, just to show you what the pandemic did to us. I mean, from 2018 to now, 215 gigabytes, the average US home nationwide went from 215 up to 462. That's way more than doubling in a couple of years. It's just an amazing growth of broadband. So the other thing we're seeing is big users are growing. Again, 2018, 4% of homes used a terabyte of data a month. Now in the fourth quarter of 2020, it's 14%. We're waiting for the fourth quarter 2021 numbers, should be out any day here, but it's just exploding of big users. And then I think this is my last slide. The really interesting thing we're seeing during the pandemic is a huge number of people have upgraded their service. A lot of you on the phone probably did. And so what you can see by comparing these two charts is that less people are using the under 50 megabits. The people buying a gigabit product has doubled, and this is just from 1 year, from June 20 to June 2021. So the people are buying the faster products, and they did that to try to fix their problems with home broadband. Unfortunately, for a lot of people, this didn't fix it, because for a lot of cable companies, the upload speed is the same on the 100 megabit to 200 megabit and the 300 megabit product. So uploading made a lot more money for the cable companies. It did give you faster download, but you may not have been having a problem with download at 100 megabits. That's a lot of bandwidth, but you certainly are paying a lot more money, and you may or may not have fixed your upload problem. So, to keep this thing moving today, that's sort of the overall high level picture. And by the way, I also write Pots and Pans by CCG, a daily blog, and today's topic is about upload speeds. It'll give you an even different view of what I was just talking about, but you can't read it until the webinar's over. So we're going to watch. So I'm going to hand it off right now to Mark Boxer. Mark is also on the NC Broadband board, and he's also, he can tell you about who he is, because he's got a great story about why he's on here today. So.
Yep. So Doug, you just take me through the slides.
You bet. So that's your first one.
Mine hasn't changed yet.
Oh, really?
And I have a fiber network.
It's on my screen. Is anyone else?
It's on mine. There
Yep,
you go.
okay,
There's
there
the
it is.
space.
Yep.
Oop, I guess that's the second slide.
Okay.
Yep. Thank you. Now I see it.
All
yeah,
right.
just a little bit of background. I'm technical manager, solutions and applications for OFS. This is my 30 millionth year in the industry. So I'm actually 34, I think 33, 34 years, and all of it in fiber. So as you can imagine, you'll probably hear something about fiber as we continue on during this, during my part of the presentation. But I work for OFS. We make fiber, cable, network, all kinds of network stuff, headquartered out of Atlanta. But the trees behind me are in rural Beaufort County in the eastern part of the state. And I say that I live in the greater Bath metropolitan area. For any of those who are familiar with the North Carolina's oldest town, the town of Bath. So Doug, how about we head on? Oh, and one thing is, I am lucky and blessed to be connected by a fiber, and so I have the best of both worlds. I have excellent communications, but at the same time live in a place that is that's very very nice, a very rural location, and communications capability has allowed me to be able to do that. So just a little bit of a history lesson, and in the beginning of a lot of our telecommunications, asymmetric was the norm. So, especially when we started looking at higher bandwidth applications. So, some of the first, the first communications, you talk about smoke signals and those kinds of things. I guess those would be, you had those going in both directions. Telephone calls were in both directions. But when we started looking at anything with higher bandwidth, asymmetric was the norm. So this is a television antenna. Ultimately, and you can see the people on the right side staring at the big old wooden box that has the TV. So this was my house growing up in the the 1960s and the 1970s. And so Doug, if you'll head on to the next slide. Yeah, so just kind of fast forwarded to the early internet. And one thing I would like to highlight, so one of the things I really love about North Carolina Broadband Matters webinars is that we typically have a lot of time for discussion. Seeing that there are some questions already coming in, so certainly feel free to add questions, and we'll be addressing those as we continue on. But with the early internet, all of the technologies were really downstream flavored, and so that included DSL, wireless, cable, satellite, and even fiber. There's been a lot of discussion about fiber from a symmetric standpoint, but up until relatively recently, even fiber was downstream favored, and this ultimately matched demand for the early internet. So I have a picture of Joseph Lechleiter, who was credited as the inventor of the first DSL patent with DSL, and it turned out that when he was doing research, he found that actually crosstalk was reduced with asymmetric speeds, and so it just it naturally enabled the technology to go in that direction. It also matched the demand for early internet, because early internet, you were getting a lot more downstream than you were upstream. But Doug, if we go ahead and fast forward now 30 years, 25 years to where we are today. So Doug also mentioned the Sandvine report a little while ago, and I really kind of like this this graphic on the right side of the screen. So Sandvine as a company is a company that they can peer into the traffic going over the internet. So you got ones and zeros that ultimately represent protocols of various types, and they have equipment that can read what that traffic is. And so and that's where Doug got the information that he shared a little bit earlier. But their point is that a terabyte really isn't what it used to be, and we are all becoming heavy users. And so one of the things that I say often when I'm talking with people is data is absolutely becoming the new power. And you think about what happened in when we started to go from scarcity of power to abundance in power, is that once we had abundance of power, then we started figuring out all different kinds of ways that we can use fire or use the electrical network. And same kind of thing with bandwidth. As you have more and more bandwidth available, then you absolutely can figure out a lot more ways to do it. And we'll be talking about that as I continue on in the presentation. But many of the trends that were formed during COVID, the COVID response, are here to stay. And Doug, really elaborated those in a lot of depth, but remote work, remote play, remote healthcare, remote learning. But all this requires significant amounts of bandwidth. And Doug looked at it kind of in an overall basis. And what I'd like to do is kind of zero in on Mark's household. So Doug, if you can go to the next slide. So this was one person, one stream on Microsoft Teams. So this was early on in the pandemic. So you could tell I had pandemic hair. I was also this was a rehearsal for a webinar. So this was using Microsoft Teams webinar feature. So pandemic hair and some really ugly glasses. But if you look on the right-hand side of the screen, you can see that when I was rehearsing for this webinar, I was tossing out 8.5 megabits per second of bandwidth for this. And so most applications are going to scale to the available bandwidth, but in general, the more bandwidth that you have, the higher quality that you get. And if you don't have enough bandwidth, then that means the quality is going to be a little bit lower, or you're going to have delays. And so what a lot of our networking engineers do, and they do a great job of this, and I think Kent's probably going to talk about this in some depth, is there is always a battle of the demand for bandwidth and compression. So trying to we have all these bits and bytes that we're trying to send down the network, and we're also trying to compress them as much as we can, because basically we have been in a position of scarcity with bandwidth for forever and ever. So Doug, if you can go on to the next the next slide. So start to scale this across the household, and these numbers are wrong, but they're not that wrong. And they are hypothetical household bandwidth needs, and every household is going to be different. But this was a hypothetical looking at just different applications that are used by different people, and you can start to see that these are some needs today. And so just looking at everybody who is on a household, and in general, we are all starting to use a lot more bandwidth. That Doug had mentioned earlier. So you use the 8.5 number that I showed a little bit earlier as an anchor stream, and you start thinking about Okay, well, other people in the household are going to be using stuff. I know in our house we've got 3 cameras floating around looking at various types of things. Downloads, updates, saving, and you've got a lot of different needs for bandwidth. And the one thing about networks is as we build networks, these networks that we build should not be built for the demand in the year 2022. We need to be thinking about when we're thinking about networks and building and making sure that we scale, we should be thinking about networks that last for decades, because you really try, in my opinion, to try and do it once as much as you can, and then use that as much as you can down the road. So Doug, next slide, please. So you look at different amounts of bandwidth for different applications. And so this comes from our friends at Calix, and digital video. If you go out to a lot of sites, you'll see a demand for 4K video, 25 megabits per second. You go out to Netflix and they'll say with Ultra HD or 4K, 25 megabits per second. I think YouTube has one, depending on your frame rate, that's in the same ballpark. So in general, it's in the 25 meg range. For 8K, the estimates are not quite as narrow, and I've seen anywhere from maybe the 60 to roughly 100 megabit per second demand. Gaining different amounts as we continue to drive up resolutions around around the different gaming platforms and video conferencing, different types. And so Doug, if you head on to the next one, so you've got other applications, digital doorbell, home fitness, Alexa likes to talk a lot. So she uses up some bandwidth, digital appliances, security cameras. Again, this continues on from Calix. And then, this is where I think it's very interesting. So, we look at that's where we were. And so these are applications where, we've been using these all for a while. So that's not a big surprise. One of the things that I've been, looking at, and we've been kind of keeping our eye, the concept of virtual reality and augmented reality have been around for decades, but and they've never really hit the mainstream in a big way. One of the things that has really caught my eye, though, is over certainly the last quarter, there's been a lot of discussion about Apple coming out with a combination of AR and VR platform. In fact, over the last several days, I've seen multiple tech industry articles about an Apple AR VR type of device that would enable theirs. And so whenever Apple starts to get into something, actually I start to get kind of interested, because they've got a pretty good track record of putting together products that ultimately people like to see. So at this point we don't really see a lot of demand for AR VR. But if we start to see the kinds of devices and applications that can drive AR and VR, now we're starting to also look at really a step change from where we are today to where we need to be tomorrow. And once again, as we're building networks have to last for decades. And so we need to be thinking about building these networks so that they are scalable over a very long period of time. So, again, these are some future application demands. So Doug, let's head on to the next slide. So, I'm part of the Fiber Broadband Association. And so, again, I'm very fiber invested. So I'm very, very open about that. But the FBA Technology Committee has put together a bandwidth demand forecast looking at projected peak bandwidth requirements for a typical household of 4. And so what we did with that, this is actually we put together literally an Excel sheet, and we counted up some of the different applications that we would see that were operational in can be operational in a household, a typical household with the different applications. So this application takes up 8 megabits per second. This takes up this much. You have this number of people using these kinds of applications, and just basically add that up. And then from there, we put that into crystal ball mode, and extrapolate, out until the rest of the decade. And what's kind of interesting here is that you can see the numbers can go potentially above, the gigabit per second number for both upstream and downstream. And what's interesting about this is that this is an FBA bottom-up kind of forecast. But when we go and we look at extrapolating demand from organizations that do testing, so like Ookla and the Cisco VNI index, so these are other ways of looking at demand. We also find that, even when you extrapolate their demand forecasts, we all kind of end up in the same place. We get there in dramatically different ways, but we all end up with, just thinking that demand is absolutely going to continue. And that comes back to the whole, data is the new power thing. As I mentioned, early on in the presentation, when we first, as people got power, then we started seeing all these different applications that we were able to use with that power. And the more we go from scarcity of bandwidth to abundance of bandwidth, then absolutely the more more applications we will need, and also the more bandwidth that will be required. So Doug, if you head on to the next slide.
Mark, just to jump in here, you're kind of running over time. So.
Yep, sorry,
Okay.
I'm almost done.
Okay.
Yep. So in the long run, fiber is the answer. Fiber can scale to meet both downstairs and up or downstream and upstream bandwidth demands long term. Other technologies can assist short term, but fiber to the goal should be, or to the home should be, a long term digital. I am messing that up. But fiber to the home should be a long term goal for digital equity. The one thing also is that we don't use, none of these are used in a vacuum, and we need to, all of these technologies need to be complementary, and you use them in different ways. And so it doesn't make sense to connect a fiber to a tractor. So there is there are a lot of different ways that you can use wireless communications and combine them with fiber, and absolutely we should be doing that moving forward. So I yield my time and looking forward to hearing from Kent.
So next is Kent Winrich, and he's the CTO of Open Broadband. So,
Morning, all. This is going to be the point counterpoint. I'm the counterpoint. So let me give you a little background on myself. Yeah, first of all, I'm the CTO of Open Broadband. We are a technology agnostic company. That means we'll use wireless, we'll use copper, we'll use fiber, we'll use anything that will get connectivity to the people that need connectivity. I'm regional director of WISPA, which is a wireless internet service provider association. I used to be the director of a Muni-owned fiber network in Salisbury. So I've actually done a lot of the fiber work. I've used GPON, I've used, actually, we turned up 10 gig fiber in Salisbury, utilizing some equipment from Calix. I used to be the senior engineer for Hibernia Fiber. I was in charge of a diverse fiber network from, part of the sub-Atlantic fibers over from Dublin to Moscow. So I had a complete fiber network that I was in charge of. I was also the senior engineer for a company called Video, which is a video compression. I will talk about that in a little bit as well. My RF background, I was director of engineering for iHeartRadio in Milwaukee. I was a regional manager for IBM, and I was a system analyst where I taught soldiers broadcast, RF technology and electronic technology. You can go to the next slide, please. Symmetrical versus asymmetrical. Symmetrical, define it, download and upload the same rates. Asymmetrical, download is faster than the upload. Just wanted to define that. Next slide, please. Examples of symmetrical: some fiber deployments, not all fiber deployments are symmetrical, and some wireless deployments. Next slide, please. Examples of asymmetrical: all cable is typically asymmetrical. GPON, yes, GPON is asymmetrical by nature. Standard GPON per port wants to be 2.4 down and 1.2 up. You can force it to be symmetrical, and we did that in Salisbury, but it was jumping through hoops. So each port is capable of 2.4 gig download per port. So then GPON, of course, is optical, a passive network, which means it goes out to optical splitters, and you split that down per port. You could have up to 32 ports on a single splitter and break it down even more. XG-PON, which is not very popular yet, but it's called like a 10 gig version. It has 9.95 down and 2.4 up per port. Some wireless is asymmetrical, some wireless is symmetrical. All cell is including 5G is asymmetrical. Down below, I have an ad for a company that does fiber, and I don't know if you can see it very well, but what their high-speed internet 50 is 50 meg down, 10 up. High-speed 100 is 100 down, 20 up, and 500 is 500 down, 100 up. So they're using GPON and are selling asymmetrical. And the gig is 1 gig up or down and 200 up. Next slide, please. Why am I promoting asymmetrical? More technologies to fill in the digital divide. If we just limit ourselves to one tool that will provide, that has got to provide asymmetrical, I don't know why we need to do that. We need to use all tools available. And also the supply chain is going to be an absolutely huge issue, particularly in fiber. It's a huge issue in wireless as well, but I'm seeing some fiber products being 2 years out. Also, it's going to help in true broadband utilization, because as I'm about to demonstrate, the real utilization is very, very asymmetrical. So if we are insisting that it's got to be symmetrical, we're spending money on bandwidth that is not going to be utilized. I'd rather spend money upping the download speed than wasting money on upload speeds that are not being utilized properly. Next slide, please. So let's talk about the utilization. I'm going to use an NCTA study that examines these traffic patterns. So they actually did a lot of the work for me, which I really appreciate them. Next slide, please. So video is the biggest usage of bandwidth, as you can see here. But look at the upstream down at the bottom. So you have 57% of the download stream is video. 2% is upstream. But going back to my codec, my video compression company I used to work for, codecs are getting exceedingly efficient. And I'm going to show you examples in YouTube as well. But you can see here, gaming is only 7%, 0.5% of the upstream. Files in cloud, 5% down, 3% up. The thing is that there's a big difference between data usage and data speed. So there's a lot of usage, in other words, a lot of data, gigabytes going up, but the usage is very, very packetized. In other words, it's very bursty. You see a lot of blips going along with a lot of spaces in between. Next slide, please. So, and actually the downstream ratio is actually increasing. So it's up to 14% now. It's going to get more and more. So you're going to see more downstream utilization than upstream utilization. Seems contrary to what some of the other presenters went, but CommScope did this study, and you're seeing more downstream versus upstream. And I'll show you an example of one of our main nodes in Eastern Carolina and show you exactly how that's happening. Next slide, please. So, and then multiple device scenarios show moderate increase. So in a mixed entertainment, the far left, you have one live game, one 2-participant video call, one 4K stream, and one HD stream. So you have a downstream of 24 megs and an upstream of 1.4. This is why the FCC has been using 25.3, because it kind of fits into that right away. And then if you want to do multiple video conference calls, my wife and I both work from home. And so we're on video calls all the time. I've set my office up. I'm actually in a separate building, my shop, and I'm running a Ubiquity link that I've shaped to be 30 meg down, 10 meg up, so that I can study this even more. And you can see I'm not having any problems. I do have a fiber feed, but that's irrelevant because I've shaped my wireless Ubiquity radio to be 3010. So we're both running video calls all the time, but you can see it's not additive. You can do a 2-group call. You got a 1.4, 1.2. The downstream gets a little higher, and then you start getting 4-group calls. The upstream gets a little bit more, but you're still, 4-group calls. You're still doing 4 megs. Quite easy to do. Next slide, please. But a lot of people are talking about 4K video or 8K video. So I used to be a video producer. I used to design sport production trucks, and if we really didn't go 4K video, we went HDR, high dynamic range video, which provides a lot better image quality, in my opinion. The codecs are getting better and better. Yes, there are 4K and 8K TVs, but very little programming. And by the way, do you remember when 3D TV was going to be all the rage? It's nowhere to be found. I truly believe that 8K is just going to kind of flounder. 8K typically transcodes to 4K, and 4K can be run as low as 3 megs. I will show you that. Next slide, please. So let's take a look at YouTube 8K. I did a wrong picture. I've taken error. I went to that 8K Ultra image down below. Next slide, please. So here we are. We're looking at the 8K Ultra channel on YouTube. Next slide. Now, YouTube's got a fun little toy, Stats for Nerds. So if you click on that, it'll give you the stats for your real utilization. So next slide, please. So this is an example of an 8K video. And if you look towards the top, the actual resolution is 3840, which means it's running at 4K. And literally, the network activity, you can see the bursts of data. I wish you could see my finger pointing right at the numbers there. But at this instance, it's actually using no data. My connection speed is 57 megs via Wi-Fi. Next slide, please. And here is, again, more data packets. We're still at 3840. But it's 2.4 megs of data for a 4K video. And this is actual moving video. These were pictures of images of fish swimming around in the ocean. So you can see that the codecs are getting better and better. Next slide, please. So this is an example of one of our nodes in a town called Mount Olive, North Carolina, which is south of Goldsboro. And I'm showing you here, this is a feed that's going through this wireless link is capable of 770 megs. It just works for what we need it to do for now. You can see, this is in the evening time, but you can see there's a throughput of 593 download, but only 32 megs up, and we're serving a couple of hundred people. This is really what it's all about right here. This is real utilization from last night to really show that, you know, a couple hundred people using 32 megs at peak utilization time. It's very clear to me that we really need to focus on getting services to people, not limiting the type of products that we allow out there. And I mean, like, if we do symmetrical, that means cable modem comes out. I'm sorry, but cable modem needs to be part of the solution, as does wireless. For example, we're able, and I think, Doug, you had a WISP in there at 4 megs. We wouldn't even serve somebody at that low of rate. Typically, our minimum is 25.3, but we are able to serve over 200 megs right now. We do have a gig customer, but new technologies coming down the line is 5 gigahertz will be able to provide 600 megs of throughput of download speeds, and non-lattice site 400 to 500 megs. So the WISP industry should also be a part of this whole solution. Again, we're technology agnostic. We don't care what it takes to get to them. We just want to get to people and fill that digital divide. Next slide, please. Oh, then that's it. That's what I have for questions. I've got my email address there. Be patient in my emails because I'm very slow to respond at times. But I'm more than happy to answer any questions that we have. And I thank you for your time.
All right. Kent, I would like, first off, could you explain to folks what codecs is?
Oh, codec is
Yes.
It's what videos are run through to compress. They compress the videos into something that can be transported more efficiently. All broadcast solutions do that. In the fiber network I had in Europe, it was, for example, for like BBC and all the major networks throughout Europe. Matter of fact, we provided fiber connectivity to the Sochi Winter Olympics. Each unit had a compression technique either built into a hardware, as a card or as a piece of software that would compress the video into something that's a little more bandwidth. Likewise, your TV stations have to compress their high def video slightly as well, because they have to fit it into a 6 megabit or 6 megahertz channel. So it compresses the video into what can be artifact free, or if you really want to compress, there is some artifacts in there.
Also, I just wanted to clarify that particular county is pretty much the equivalent of Cherokee County here, 100% woods. And so their WISP speeds are low. It's probably 10-year-old radios and 100% woods. So yeah, it's not a great place for wireless technology. It happens to be one of the biggest ISPs in the county. They have a lot of customers, but the speeds are not good. So yeah, it's not nice and open like behind you there. So yep.
Well, we're in deep woods as well, and our CBRS product is we're anticipating 175 to 200 meg download non-line of sight. And then there's the other product which will do 400 megs non-line of sight.
We did have a question from the group, just to clarify. We are definitely going to put these slides up on our website probably as soon as we're finished here, and so they will be available to everybody to see. Let me run through the chat here and see what kind of questions we have, because I couldn't look while we were talking because everyone would have seen it. So let's see. We have not gotten a lot of questions from folks here. So
can I just chime in on one other thing that I think I neglected to have in my slides? So it's great that people have fiber and other fast means of getting to the home, but typically most of your users are using Wi-Fi, and most of your users are connecting by 2.4 gigahertz, which means that your speeds are going to be knocked down anyways. For example, my TV, which should be on the 5 gigahertz band and able to provide much better bandwidth, is still stuck on 2.4 and still able to provide 50 megs. So unless people are wired, your gigabit connection is really not going to be very beneficial, because most people are still running off a single Wi-Fi router.
And I certainly agree with that. I mean, very few homes are actually capable of accepting a gig. It's sort of a silly thing. So I still kind of think that, except for the rare household, a gigabit product's more of an ego product than anything.
I agree, and we can provide it. So I mean, it's like, you really want it? Okay, pay us the money.
One of the questions we have, which went to a comment I made, wants to talk more about speeds that vary, because we all see that. I mean, I'm on a cable company, and the speeds literally vary by hundreds and hundreds of percents from minute to minute, and that, where I see that in talking to folks is when you're on a slower technology. If you're on a rural DSL and your speed varies, then boom, it gets slow and it kicks you off. I mean, I can't tell you how many rural, webinars or Zoom calls I do with people who, 5 times an hour get kicked off and have to come back on. And it's not because they don't have enough bandwidth. They don't have enough bandwidth for a very short period of time, and it boots them off of the Zoom. And so if you only got 2 megabits to start with going upload, if your speeds are not decently constant, then you just get nailed. So no, faster technologies, that's not going to happen. The other issue that we see, that we've seen, is, again, we do a lot of work in places where it is the rural technologies, where it is DSL. That's where the neighborhoods get really full and get locked up. It's a lot harder. I don't know that we've seen a whole lot of neighborhoods locking up on cable, and we certainly don't see anybody locking up on fiber. So any thoughts, you guys, on variableness?
It's so variable. So
it's variable.
Not to be a smarty pants answer, but it really depends, because on the provider that I use a thing called Ping Plotter, and I see where their choke points are, and sometimes the choke points are out of their control. Sometimes it's the provider to them. And that's so it depends, I guess, is probably the best answer. But it's also how the network is designed. If it's not designed to be able to handle that extra headroom, then you're going to have choke points within your own network. And so I think some of the old designs, particularly, well, DSL, all bets are off on DSL because, you know, the FCC doesn't even support it anymore. But some of the old cable designs have a lot of choke points.
Right.
Yeah, I mean, to me, I'm always going to come back to something very fundamental, and that is abundance versus scarcity. When you have abundant bandwidth, all the stuff goes away. And so, you know, so when you are deliberately limited, then I mean, you really do have to depend on the codecs. You have to depend on really everything becomes a lot more complicated. And so, you know, the more bandwidth you plan for, and the more headroom that you plan, I mean, everything else becomes a lot simpler.
Next question. Anyone want to grab here and talk about the question? What's Wi-Fi 6 and the 6 gigahertz spectrum going to do for us at the homes?
Yeah, I got a Wi-Fi 6 box over here. I haven't taken it out of the box yet, but I don't see it as a really big deal right now because 5 gigahertz can provide plenty of bandwidth. I mean, if you're going to need a gig or 500 megs or something like that, you need to be wired anyways. If you need completely reliant conditions, you need to be wired from your wireless. And that's work with me on this. So I've got a wireless connection here, but I'm wired into my laptop, so I'm not utilizing Wi-Fi. There's two different technologies there. I think Wi-Fi is somewhat an unreliable technology. I'd rather see that 6 gigahertz be given out to providers as opposed to just, you know, have the biggest box with the most antennas on it. That seems to be the way to go for some people.
And I would add, I mean, we hear from a lot of service providers, Wi-Fi continues to be a choke point. And so, you know, hopefully there is enough attention on that to, you know, to help us to begin to see some solutions, because, you know, we are seeing that, yeah, we're now seeing a lot of bandwidth being available to a certain point, and then hopefully, you know, we'll clean up the last part with some better Wi-Fi, you know, technologies.
Well, my take on it is I live in a city, and so that's where I'm seeing the problem with Wi-Fi. I mean, just from my house, I see almost 80, sometimes 90 other people Wi-Fi routers.
Yeah, that's
and that's where the interference really, you know, and so it's not even what I'm doing in my house. My Wi-Fi router tries to look at all 80 of those over and over and over again. It just gets to be a real mess, right? So, and so I think in a city like this, no, I agree. You know, I think we have to break the spectrum issues into the city. I would love to have faster Wi-Fi in my house, but I think in rural areas they ought to absolutely open up 6 gigahertz for broadband, and that's sort of a double. You know, I think we can benefit everybody. I think we have to get a little more selective of. I like your ideas. Let's find what works and make the darn thing work. So, so yeah, it's not so much fun when my Wi-Fi does die. It does get into problems here. So again, because I can't always direct my devices to the channels I want them to go to because they're hard coded in when you buy them, right? So I wish I could. So let's see here. Let's see, this is aimed at Mark. Is there any good reference to month-to-month cost benchmarks and predictions of buying bulk fiber? I'm not sure that.
Yeah, I mean, I thought I would go ahead because there were a number of questions about fiber, and I thought I would just go ahead and address that, you know, just to give a little bit of update as far as, you know, some of the challenges that we are seeing. So, you know, I am hopeful that we're going to see supply chain challenges begin to abate as we get deeper and deeper into the year. But I mean, there have been challenges on, you know, a lot of different fronts. So, you know, you start with transportation, you know, transportation challenges, receiving materials in from ports. There have been challenges with just the amount of trucking capability, both to bring raw materials in and then to ship, you know, materials back out again. There have been raw material challenges, through pretty much all part of the, all components that go into, a fiber optic network. So, I'm cautiously optimistic that as those supply chain issues begin to work themselves through, that we'll see a little bit more capacity show up. But I'm not hearing 2-year numbers. I'm hearing numbers that are a little bit less than that. But absolutely, it is a supply chain will continue to be a challenge, at least for near term on a number of fronts. The other thing that has been a challenge, and I hope is going to be beginning to abate itself as well, is just trying to keep people healthy in order to work in manufacturing facilities. That especially with the Omicron version of COVID, that hit a lot of places very quickly and very hard. And so starting to hear signs that those types of issues are abating as well. So hopefully we'll see the industry be able to respond a little bit more. But I don't think we are. I don't think we're out of the woods for a while.
Yeah, I think we're going to get worse before we're going to get better, which is sad. So we're doing a lot of buying right now as we can get it. So it's going to be a lot of catch up to do. That's for sure.
Yeah, and my take on it is, because I work with a whole lot of communities trying to do broadband for the first time, the supply chain issue is really different for somebody who's been buying fiber for 10 years. They go to the top of the list. If you've never bought it before, good luck in finding someone to sell you any of it right now. I mean, I have a lot of small guys wanting to buy fiber for the first time and pretty much being told to go somewhere else and look for it, or being told that their delivery is so long that they're never going to get it. So the supply chain is not even. So AT&T had problems this year. They ended up about 500,000 passing short. They said in 2022 they're not going to have a problem. So they've been promised to get their fiber somewhere or the other. So the world is unfortunately not always even. But a lot of the communities on this call are going to be tackling little tiny fiber projects, and you're going to have a challenge with that. Those are the hardest ones to do right now. So I don't see any other questions if you're looking through the things too.
I see one that Steg Newman had. For 5 gigahertz technology, do you need clean line of sight? And if for line of sight, how close do you have to be to the cell site? Most 5 gigahertz likes line of sight.
Yeah.
And how close do you have to be? Well, we've got one that's 10 miles out, still providing 120 megs. For non-line of sight, there's another technology called Tirana, which will do 5 to 600 megs, probably, let's say 400 to 600 megs non-line of sight. And the computing technology on that is just incredible what they've done. So, and it's even better with 3.5 gigahertz, which is called CBRS. The non-line of sight, we've done 10 miles non-line of sight and provided 75 megs. But the Tirana technology, all bets are off because that's a brand new thing that's coming down. And by the way, it's built in the US and Mexico. So the supply chain, they're spooling up, but it's at least doesn't have to be shipped across the seas.
Yeah, that's brand new, and of course, so we'll have to just see how soon we can actually buy it.
Well, it's actually been deployed out there. There's some in Illinois and Indiana, and the speeds coming back are just insane. I'm glad to see some other technologies. Again, more tools we get in our quiver, the better.
One of the questions at the very end by Terry Buckner asks, your argument, if you want to read it there, the argument that we should, serve as many people with what we can as possible. She's worried about the, with sticking with the 3 megabit download or upload speed definition. So
there's a comment in chat: isn't oversubscription the bottleneck? It seems fiber networks would be more forgiving. Oversubscription is something that needs to be calculated. It doesn't matter what the network is. So in other words, for example, I'll go back to Salisbury. Salisbury, when we started out, we had 3,000 customers on a single gigabit fiber connection. And yes, we were serving gigabit service up because it's all bursty, and it's called oversubscription. It can be a bottleneck if the network is not designed properly, and it really doesn't matter if it's fiber or whatever. It just needs to, the oversubscription needs to be taken as part of the calculation to designing the network. I hope that makes sense.
Yeah, and another take I have on it, because I've seen, again, working all over the country, we definitely see networks that are massively oversubscribed. I mean, some ISPs have, I mean, they just put way too many customers on a given node of technology. But if you design it right, you know, it's not an issue. You know, the cable companies were the perfect example of that. They, if you all remember, 8-9 years ago, everybody slowed down to the evening, where the point where you couldn't watch anything on TV, and they finally just decided to go and fix the problem, and they mostly cut down their node size, and you don't really hear about it much anymore. So I mean, that was the #1 complaint about them, but you don't hear anyone talking about that anymore. It's not an evening issue anymore. It's a neighborhood issue. My neighborhood's good or bad, but not the city's good or bad. So, you know, the ISPs are very attuned to oversubscription. You know, there are good, and what I always say, there's good and there's bad ISPs. There's some guys who don't deliver a very good product, and there's guys who deliver world-class products, and you just, hopefully you get the chance of the good ones. So, and I think you got some good ones here in this group. So I think that, you know, unless anyone has any other questions to answer, I kind of think we've hit our time limit here. So if Krista or Catherine see a question here you'd like us to answer?
It does look like you all covered them.
Okay.
So we might just go ahead and wrap up.
It's just Catherine. Terry had she had entered a question, and I don't think we totally answered it. I don't think anybody answered it directly. What it says is, I understand Kent's argument to design a network that serves the maximum number of people, but I don't understand the argument against greater than 3 megabit download speed. What's wrong with planning for a download speed that meets future need for bandwidth?
Okay, and I guess I wasn't very clear. I'm not against greater than 3 megs. Absolutely not. I'm just, let's go. But my comment is that I believe asymmetrical is a wiser use of bandwidth. So, you know, we have services where, you know, 200 meg down, 100 meg up. I have nothing against going greater and planning for the upload speeds in the future and the download speeds as well. Yeah, I'm not against that at all. I think it needs to happen, and we need to be planning, no matter the technology, we need to be planning for future utilization. And there was another one, when is Wi-Fi 6 going to be widely available? It's available now. It's just that people are having a hard time getting devices in, and you're going to see pieces here and there. Widely available, give it a year or so, and you probably will see it, but you can get Wi-Fi 6 devices now.
Right, but until you actually convert all the devices in your house to it, you won't really be using it. So
there's that. Yeah.
If you've got a TV that doesn't use it and a computer that doesn't use it, it doesn't really help you to put it in. So exactly. I think it's going to be 5 or 6 years to the average house is really using it. So you know, you have to go out and replace all your electronics. That takes a while.
A lot of big USB dongles going out there.
Exactly. So yeah, I think Krista, if you want to go towards the wrap up here. You're muted, Krista.
All right. I'm here. Shall we close out?
I think so.
All right. Well, thank you so much. Always an enlightening discussion. Lots of fun. Thank you, Kent, Mark, and Doug. We will do it again next month, where the topic is agriculture and the need for broadband on the farm. So look forward to that. Please check out all our past webinars in our archive at nchartsgigabit.com. And we welcome any questions from you in the meantime at info@nchartsgigabit.com. Thanks so much, guys, and we'll see you again real soon.
Great discussion, all.
Thank you.
Appreciate it. Appreciate it very much. Have a great day.